Okay, let's start. I'm Teruaki Enoto from Hakubi Center, Department of Astronomy from Kyoto University. I'm not an English native, but I talk in English. So my talk is not useful for your English listening for the student, but my message, I hope, become useful for your future career or life. And probably you would imagine from my affiliation, and thank you for your introduction. I'm an astronomer or astrophysicist. And every time I introduce myself as an astronomer, people would imagine that astronomers are watching stars in the sky with enough knowledge of the star constellation, like the Sasolita in the Scorpius. However, this is not true for me. That I'm usually using satellite observatories because I'm an X-ray and gamma ray astronomer. The X-ray and gamma rays are high energy photon, high energy light, much higher energy compared to the optical light, which we can see. And this kind of high energy light cannot penetrate the Earth's atmosphere, and we have to launch the satellites to observe the stars. And the X-ray astronomy has revealed the very active universe, including the black holes, supernova remnant, Choshin-Sezan-I, and cluster of galaxies, Gingadan, and etc. And this is a very famous illustration from the famous movie, The Interstellar, based on the very accurate scientific knowledge. But this is just an illustration. And in reality, when we observe the black hole, we record this kind of image in the X-ray band. Even that this kind of very simple image, we can extract a lot of information from the black holes and the base of the stars, etc. And everybody would love the black hole, but I love much minor object. My favorite object is a neutron star. Neutron star is the densest object in our universe. That is very, very small. The diameter is 20 kilometers or so. It's almost comparable with the size of the city of Kyoto. But the neutron star has a huge mass inside it, almost comparable with our sun. And inside of the neutron star is still a mystery at the modern science. And we have to know what kind of stars is happening in the neutron star. And also, this star is very strongly magnetized, like a very strong magnet and spinning. And sometimes we call these pulsars, and pulsar emits the pulses of X-rays and radio, which come to the Earth. And when I was working at NASA, I was a member, just a member, of this project called NICER. This is a neutron star interior composition explorer to resolve the mystery of the inside the neutron star to collect a lot of X-ray photons from the neutron star. And I love this project very much. And getting the information of this neutron star, we can resolve the questions of inside. And another attractive aspect of NICER is the neutron star become the very precise clock. And we can use this clock like a GPS system when we go to the deep space. So the NICER is very attractive, not only the science, but also the technology. So this is neutron star. And again, this is a neutron star system, the Club Nebula, and you can feed the central compact object, the neutron star, and the spinning of neutron star spread out the high energy particles outside this system. This is called the high energy cosmic rays. And these cosmic rays fill our galaxies and coming to the Earth and hitting the Earth's atmosphere. So if we raise a hand and to see the cosmic rays, if you can see the cosmic rays, you would realize that the cosmic rays hit you and penetrate your hand, 1 per cosmic rays per second. But probably you cannot see. So I have one detectors. So this is special detector to get the cosmic rays. And when you see the red flash of this LED, this means this detector is hit by the cosmic rays. But this is random. So sometimes this will become red flash. So, well, you will see. But let me continue. And it's with flash. Okay? And here's another mystery. The lightning, kaminari, is expected to relate it with cosmic rays. Or someone says the lightning would be triggered by the cosmic rays. This is amazing stuff because the very familiar phenomenon, lightning, would be related with the cosmic rays, comes far away from the Earth. So I'd like to challenge this mystery. And I decided this topic as my master thesis when I was a master student already 10 years ago or more. And I developed this instrument, detector, the 放射線検出器 radiation detector as my thesis. And what I want to try is to detect the gamma rays from, that is high energy, photon high energy light from thunderstorms and lightning. So this would be a key to resolve the questions, the mystery of lightning. And Japan is a nice place to study this kind of topic because in winter, thunderstorms from the Siberian low pressure system make a very huge and energetic winter thunderstorms and lightning along the Japan seaside. And this is a very special place to study this topic. And after my 5 years in the United States, I came back to Kyoto University in 2015, and I decided to launch a new project to observe the thunderstorms as a mapping project. So what I want to try is to observe the thunderstorms in a gamma ray detectors, spread it out on the ground. So this is the concept of my project. And to detect the gamma rays, we use this kind of special crystal called the scintillators in it. And this can detect the signals from cosmic rays or high energy gamma rays. And we also need to develop this kind of special electrical board to extract the signal from this crystal. Oh, this is very fun. I love to make this kind of detectors. But the point is, these kind of parts are extremely expensive. Sometimes 100万円, 10,000 yen or so, $10,000. So the problem research fund. So when I come back to Japan, my main research field is astrophysics, but this is somehow different. So I have to propose the request to the government, please give me my money for this project. However, our original proposal was not accepted by the government and the reviewers. Reviewers said the science seems to be interesting, but the prospect of successful detection is not so high, so we cannot accept your proposal. So this is a problem. But I want to do this. Then I decided to challenge the academic crowdfunding recently launched in Japan as a platform called Academist. And we made these movies with my friend Yuasa-san, collaborator, and we launched this on the website. But the problem is, again, there are the limitations. We have to succeed within the 2 months. And if we cannot succeed, say, if we cannot get 100万円 within 2 months, we cannot get anything. So we tried hard, and finally we have received 160万円 corresponding to the 14 kilo US dollars, and with the supporters of 153 people. Thank you so much. And to advertise our project, we use a personal blog, academic journal that is organized by the Academist platform, and the Twitter and the Facebook as well. And during my project, we received a lot of messages from supporters. For example, I previously living along the Japan sea coast, and I remember the winter lightning, and I'm very interested in this project, and I would like to support. And finally, we received 93 messages, which are very encouraging and push our project ahead. And we also prepared some so-called return, that is a gift to the supporters. that is similar to the Furusato Mode in Japan. And this is the original T-shirt for our project, which was designed by the professional designer. And this is another mug cup. And we also prepared some acknowledgement for the professional journals for some supporters. Again, thank you so much for your support, and we can start our project in 2015. So using these financial support, we launched and started to the development of new detector. These are the new detector, but probably you do not want to listen to the detail. But to summarize, the original bigger instrument to become much, much smaller into the very small waterproof box, and also cutting the cost to make these instruments. So last year, we installed these instruments in summer to the two high mountains, Norikura Mountains, and also Mount Fuji. And also we distributed these to the 4 cities. And individual cities have different locations to install the instrument. There's another collaboration with high schools, because we want to get the place and also the power plant dengen to run the instrument. And there are a lot of high schools in individual cities. So I went to each high schools and to discuss and advertise and get the collaboration with high school teachers. Then we install these on the roof of the buildings, and sometimes at the mountains. This is Mount Norikura, and also on the roof of the Science Museum, Komatsu. Okay, and this is a memorial photo. After our installations, we took a photo with a main collaborator, Wada-kun. He is a PhD student, and we had some board with name of supporters to be installed with the detectors. And even though the reviewers said the prospect of successful detection is not so high, in reality, we detected a lot of gamma rays from the thunderstorms. So we have to write the papers, and we are now trying very hard to go to the next step. But this is another story, more scientific ones. So going back to the main story, what is this? This is the image of the whole knowledge of our human beings. And what the scientists want to do is to expand a small part of this knowledge with adding new ideas, new technology, new scientific results, etc. But in the real case, the individual scientist has only the small fraction of the knowledge. So we need collaborations. In the previous days, the researchers have a collaboration among the researchers themselves. This is important. But using the internet, there are another possibilities to collaborate with citizens and also private companies. This is what I learned from my experience of the crowdfunding. And to tag up of these different field peoples, there must be some core. So in the scientific project, I believe the core would be wonder or the curiosity, hawkism, that can make one change. And I would like to call this open science. What is open science? There are several terminologies, but in the US or UK, there's a new platform in the website called, for example, Zooniverse, where the citizen supporters can join in the scientific project. This is one example, Galaxy Zoo. In the Galaxy Zoo, the supporters can classify the image of galaxies into several types. And finally, they already published a lot of scientific papers based on the citizen participating project. Another example is a Planet 4, where the people classify the patterns on the Mars surface for the scientific project. So in Japan, not so a large community, but we launched a new small group, Open Science Meetup at Kyoto, to facilitate and enhance the collaboration between researchers and scientists. And we have been performing a monthly regular meeting. So if you are interested in this, so please check this Kyoto Open Science website. Okay, at last, what is the next? What age we are living in? So I went to Florida to see the launch of rocket by SpaceX. This bring our X-ray detector to the International Space Station in June, and this is amazing and emotional experience to see the rocket launch. I have additional amazing and emotional experience after this. This is the same launch, but say 5 minutes later, I saw this. The first stage of rocket was coming back to the ground and successfully landed on the ground. I've never seen this. And SpaceX have opened a new way to go to the space much easily with a low cost. So the space science will be also changed. And do you know what it is? Some of you would easily remember. This is a re-entry of the asteroid probe Hayabusa. So it was my surprise to know that a lot of citizen supporters can share the enthusiasm, 情熱 or passions with scientists for the scientific project. So this would be the core to push the project ahead. Okay, so science with infinite fun and wonder would be what I try to propose, the core of the collaborations. And going back to the main topic of this session, the strengths of my idea, in Japanese, 理想の力. My answer from my experience is the collaboration with people from different backgrounds. So for the student, for example, when you try to the entrance exam, you have to solve all the questions by yourself without any help outside. But after graduating or even in the undergrad, you can collaborate with other fields and you can get any kind of support or advices from other people. So the collaboration will give you some power to enhance your project. And you can imagine a lot of types of projects. Okay, that is my message. And see you at Mars for the next meeting. Thank you so much.